Okay, good morning everyone. This is Sir Don and this is our first lesson for the third quarter about axiomatic structure of the mathematical system in geometry. In short, the proving that we're going to use here in geometry is based on the axiomatic structure, which means that axiomatic structure is composed of statements that are true. It can be undefined terms, postulates, axioms. So we're going to use this in proving. So these are the objectives that we're going to attain at the end of this lesson. First, you're going to describe a mathematical system. Second, you're going to illustrate the need for a axiomatic structure of a mathematical system in general and in geometry in particular, defined terms, undefined terms, postulate, and theorems. So these are the terms that you will be encountering. The first one is axiomatic structure, or we call this one as the postulate system. So this is any set of axioms from which some or all axioms can be used in conjunction to logically derive theorems. So when we say axiomatic structure, these are composed of undefined terms, postulate, theorems, which are being used in proving. So this is the type of structure that we'll be using, or the mathematical system that we will be using in geometry. So axiomatic system can be an axiom or a postulate. So this is the type of mathematical system under geometry. We also have undefined terms. So these are terms that cannot be defined because they can only be described or illustrated. So there is no precise or concise definition. These terms are not defined. However, we can illustrate this one, or we can represent this one, just like a point. Point can be represented, but point has no definition. So the three undefined terms are point, line, and plane. So these three undefined terms are the foundation of geometry, and we can use this one in defining terms related in geometry. If we have undefined terms, we also have these defined terms. So these are terms with precise and concise definitions. These have exact definitions, like we have the definition of right triangle. So as you can see, there's our definition of right triangle, the definition of supplementary angle. So all these terms have exact, precise, and concise definitions. So you can use this one in proving. We also have postulate. This is a statement that is taken to be true to serve as a premise or starting point for further reasoning and arguments. So these are statements that don't need to be proven. These are accepted as true even without proof. Just like the ruler postulate, the segment addition postulate. So those are examples of postulates. So these are another examples of axioms or postulates by Euclid of Alexandria. So he's actually the father of geometry. The first one is a straight line may be drawn through any one point. So given any two distinct points, there is a line that contains them. So we have 2 points. If we're going to connect these 2 points, that is actually a line. So a terminated line can be produced indefinitely, or any line segment can be extended to an infinite line. A circle can be drawn with any radius and any center. So given a point and a radius, there is a circle with center in that point and that radius. All right angles are equal to one another. So we know that already because there's no other measurement for a right angle except 90 degrees. If a straight line falling on two straight lines, making the interior angles on the same side less than two right angles, the two straight lines, if produced indefinitely, meet on that side on which are the angles less than two right angles. So we call that as the parallel postulate. So we'll be encountering this one in the next lessons. Okay, so we also have this theorem. So this is based, or this is statement proven based on axioms, other theorems, and some set of logical connectives. So this is their structure. So this is the axiomatic system. Again, axiomatic system is a mathematical system of geometry. This is where we base in proving we're just going to base the proving on the true values or truthfulness of the statement. Then axiomatic system can be an axiom or a postulate, or that can be a theorem. Axiom or postulate, these are accepted as true even without proof, and theorem, however, on the other hand, needs to be proven before accepted as true. Then we also have this corollary, or a theorem that is usually considered an easy consequence results of another theorem, and we have the lemma, or generally used to describe an auxiliary fact that is used in a proof of a more significant result. So if you're going to look at the structure, we have here the axiomatic system, the mathematical system of geometry. We have this accepted as true even without proof, and we have here the statement that needs to be proven to be true before accepted, and that is theorem. Below that are the corollary and lemma. Corollary and lemma are short statements that support the theorem. So these are statements that support the theorem. So if you're going to connect all those terms, you can actually make the structure, and that is your task in this lesson.